My name is Wang, and I'm a second-year student in finance. Today, I will explore how to prepare a final report for this class. This presentation will guide you through the entire process from data preparation to analysis, and we will use Python. And this presentation will contain three parts. Okay, before using Python for data analysis, ensuring data integrity is crucial. We need to verify that all necessary variables are present and that there are no excessive missing values. This ensures that the analysis will be based on reliable data. And you can see this is the data I will use in this demo. And it's like a panel data form. And my dependent variable, y, is the z-score, which measures risk-taking. In finance, a higher z-score indicates lower risk of bankruptcy, while a lower z-score suggests higher risk. As a result, we want it to be higher. And the independent variables and control variables include total assets, debt ratio, board ownership, manager ownership, net income, PB ratio, and company age. And the dummy variables are the financial crisis period and pandemic crisis period. And you can see the y, x, and dummy variables here. So once the data is prepared, we proceed with the analysis using Python. And we have 10 steps. Step 1 is to check for missing values. We need to identify and fill missing values with the mean to maintain data integrity. This step prevents biases in the analysis. And step 2 is to convert financial data into a standard format, which helps in comparing different variables on a similar scale and improves the accuracy of the model. And step 3 is to construct a correlation matrix. This matrix helps in understanding the relationships between different variables. It is crucial for identifying potential multicollinearity issues. And step 4 is to find the p-value for each variable. A low p-value indicates that the variable is a significant predictor of the dependent variable. And step 6 is to choose variables and perform regression model analysis. We will select variables based on their significance and feed them into a regression model to analyze their impact on the dependent variable. Step 6 is to check linear relationship. We need to ensure that there is a linear relationship between the independent and dependent variables, which is a key assumption of regression analysis. And step 7 is to check multicollinearity. We will use the correlation matrix and variance inflation factor VIF to detect multicollinearity. High multicollinearity can distort the results of the regression analysis. And step 8 is to check autocorrelation. We need to ensure that residuals from the regression model are not correlated with each other, as this can invalidate the model's assumptions. And step 9 is check heteroscedasticity. We need to verify that the variance of residuals is constant across observations. Heteroscedasticity can lead to inefficient estimates. And step 10 is check residual distribution. We will use the KS test and QQ-plot to confirm that residuals are normally distributed, which is another assumption of regression analysis. So, in the coding phase, we implement the analysis steps in Python. The initial step is to import Python libraries. We use libraries such as pandas for data manipulation, NumPy for numerical operations, and state models for statistical modeling. And we will read file and check for missing values. We load the dataset and handle any missing values to ensure the dataset is complete and ready for analysis. And we will standardize data. We apply standardization techniques to financial data to facilitate comparison and improve model accuracy. And then we construct correlation matrix. We generate a matrix to visualize the relationship between variables and identify any potential multicollinearity. And here it is. We can see the net income and the total assets has a high correlation. So we will only choose one between the two variables. And then we will calculate p-values. We will compute p-values for each variable to assess their significance in predicting the dependent variable. And this is the result. As we can see, the p-value all less than 0.5. And step 5 is to choose variables and perform regression model. When we feed the selected variables into a regression model and analyze the results and interpret. And step 5 is to choose variables and perform regression model. We feed the selected variables into a regression model, analyze the results, and interpret the coefficients. And this is the OLS model summary. And we can see the p-value are all small. Then we will check linear relationship. Draw some plots and draw the correlation matrix and check the BIF. And we can see the explanation here. We usually want the BIF are less than 10. And we can see the BIF only 1.1, 1.2. So all variables BIF values are within acceptable range. And we check autocorrelation by Durbin-Watson test. We can see my data has a significant positive autocorrelation. And it is because my data is like a panel data. So the residuals will have some relationship. We check heteroscedasticity by performing PB test. We can see the PB test p value is 0.005. And here's the short interpretation of results. If the p-value is less than 0.05, the null hypothesis can be rejected, which means the presence of heteroscedasticity. Then we check residuals distribution by KS test. And the KS tests indicate that the residuals are not normally distributed. So we draw a plot and see there are two extreme values. So we need to deal with it, maybe drop them in the future. And we draw the plot to see the residuals distribution. And we can see there are two extreme values. So this is the final result. We see all variables has significance. And the relationship between dependent and independent variables are correct. Okay, thank you. And now we can see the code. First, import libraries, and we load the data and check missing values. When there are no missing values. And standardization. And then we check correlation matrix. Okay. And we calculate p-value. Here are the p-value. And we run the model. This is the result of my estimates. We check linear relationships and draw correlation matrix. There's no high correlation. We check the VIF, all less than 10. And the Durbin-Watson test. significant positive autocorrelation. And check heteroscedasticity by PV test. And here's the p-value. Check residual distribution. Did you plot here? Distribution here. And finally, print the results. Okay, thank you.